Morning, everyone. On behalf of the Southeast New England Program Network, welcome to our webinar titled Stormwater Tree Trench Design Options Guide Training. This is brought to you by the Southeast New England Program and the Providence Stormwater Innovation Center. My name is Leah Soloway from the New England Environmental Finance Center, and I'll be assisting with logistics for today's program, along with Peng Suti Sumbat, also from the New England Environmental Finance Center. And just before we get started on the webinar, I'd like to give you a little background on the SNEP network. The SNEP network's mission is to empower communities to achieve healthy watersheds, sustainable financing, and long-term climate resilience through management of stormwater and restoration projects. We focus on building local capacity by providing no-cost trainings, webinars, and technical assistance to communities in the SNEP region. If you'd like to learn more, please visit our website, snepnetwork.org. for more information. Before we get into the webinar, there are a few logistics to keep in mind. First, everyone will be on mute to ensure audio quality. This will also allow you to ask questions by typing them into the questions box in the Zoom control panel. And we look forward to answering questions, so please type them in at any time. And now that we have a lot of you guys in the webinar, I'd like to hand things over to Ryan Kopp, Stormwater Coordinator with the Audubon Society of Rhode Island.
Okay, thank you, Leah and Peng and the rest of the SNEP network for all of your help with technical assistance for this webinar and for helping promote it. For those of you that aren't familiar, the Providence Stormwater Innovation Center is based in Roger Williams Park in Providence, Rhode Island, where the city of Providence has implemented over 40 green infrastructure practices. And the Innovation Center has been monitoring these systems and the surrounding water quality to try to better understand the effectiveness of different design features and construction processes that were used during the implementation, and then the ongoing maintenance schedules of the BMPs. We also incorporate all of these green infrastructure practices into our public outreach efforts by working with local school programs. We hold a yearly arts and green infrastructure festival in the park. We've created educational signage and displays to let people better understand the projects, and then by giving different tours of the green infrastructure practices to the public. And then the final part of our mission is to organize trainings and presentations and webinars like this one for stormwater professionals, for all of you that are in attendance. So after this presentation and webinar, I do encourage you to go to our website to check out all the information and data and maps and videos and reports and that's all related to the different programs that we are working on at the Innovation Center. So today we've got a great presentation with a great group of presenters. Our first presenter will be Ellen Biegert. She's the landscape architect with Horsley Witten. Brian Burns will also be presenting. He's the Deputy Superintendent of the City of Providence Parks Department. And Brian Kuchar, Associate Principal at the Horsley Witten Group as well. And we do have a full bio page for the presenters if you go to stormwaterinnovation.org/training if you want to find out more about them. So with that, I will pass it over to Brian Burns.
Thank you, Ryan. Welcome everybody to the training today. Brian said, my name is Brian Burns. I'm the Deputy Superintendent of Parks in Providence and a proud member of the Providence Stormwater Innovation Center. So we're talking to you today about tree trench design and the options that you have as a landowner on what type of tree trench you can install. So for our agenda today, we're going to talk about why we created the guide. That's first, and then what is it and how to use it. After that, we'll break for questions and then provide a mock scenario. So Brian Kuchar and I will go through the process of using the guide so you can see how it would develop and how you would go about it, using it in your own situation or scenario. So with that, why did we create the guide? So a lot of you may be familiar with tree filters. Tree trenches are similar to tree filters. For the most part, tree filters are proprietary type elements that come in certain structures that may at times be difficult to implement in certain areas. And I'm not saying that tree filters, the proprietary tree filters, are not useful. They are incredibly useful and they provide a lot of contaminant removal. What I'm saying is that there are situations here in Providence, and we do a lot of stormwater work, where some of those things didn't work for us, square peg in a round hole type situation. So what we did was develop different options and ways to create similar contaminant removal and sediment removal in ways that can be stick built. So you can take certain specific elements and incorporate them and achieve a similar result. And in particular, in older cities like the city of Providence, we have a lot of things that we have to deal with. Narrow streets, we have utilities that often are in the way of what we want to do. So we found that it was easier for us to go project by project and stick build these certain tree filters with different elements specific to contaminant removal and sediment removal incorporated in each one, but different in every one. So with that, we asked Horsley Witten, with funding through the SNEP network and the Stormwater Center, to create this guide. So while consultants like Horsley Witten are always needed, what it does for you as a municipality or a landowner is gives you an idea of what you're looking for before you enlist a consultant, or a tool to talk with the consultant to make sure that you're getting what you want. And typically, if you can use this process and stick build things in general, it'll be less money. So it's economical. It can provide the same results as a more expensive thing, and also adapts to your surroundings. You may have a historical area. You may have a more rural area. So sometimes these proprietary things are concrete. They stick out. We like to blend all of our stormwater elements into the surroundings. So a historical area may have more historical elements. So with all of that, we think this guide can help you get through the first step of, I have to install one of these things here in this area, and I need to do this with it, reduce phosphorus, reduce nitrogen, whatever your issues are. And then this will kind of push you through the process, and that allows you to meet with a consultant and go through this with them. So hopefully it's useful everyone. We think it will make stormwater management a little bit easier for people that may not have a lot of experience with it. And that was the reason why we moved forward with it. So with that, I'm going to pass it on to Brian Kuchar from Horsley Witten.
Thanks, Brian. So I'm just going to go through really quickly sort of how to use this guide, and then Ellen Begert's going to take sort of a deeper dive and go through each one of these sections. So what's in this guide is really basically three main sections. The first being the purpose, really, Brian sort of outlined that. But the guide was developed as a companion to existing design manuals to help municipalities and designers create and maintain greener, healthier, and more resilient tree trenches. It's a tool to assist with the design process, given specific stormwater objectives, your site context, the aesthetics you're looking for, tree health, and maintenance capabilities. I just want to point out that it's not intended to be a prescriptive one-size-fits-all approach, but what we're hoping is that it will encourage more creative, multifunctional design approaches, incorporating trees into the landscape as part of this stormwater process, and to meet each of the project's needs, goals, and budget. One more caveat, I just want to add that the guidance pertaining to regulatory requirements, your sizing criteria, and construction details specific to the practices are not included in this guide, and you really should be referring to your state or local manuals, stormwater manuals, or guidance documents for that type of information. The guidance, the next section after we go through the intro is how does it work, and we'll go through that briefly in a moment. And then there's also a section, and there's a typo here, I apologize for that, how to use this guide, which really is the main focus of today's presentation, followed by trees and good practices. The reason why this was incorporated into the design guide is that we really would like the trees to be a centerpiece of the practice, and we really believe that taking into consideration the tree's long-term health and sustainability is a really important piece of the design process. And then the last section is really broken into two categories, which is surface and subsurface practices, which I'll discuss in a moment. And that includes components, and there's 5 really main components of each one of these types of tree trenches, which we'll cover. It then rolls into a design matrix, which gives you options for each one of those components or steps within the process. And then we provide some typical layouts to show how all of this comes together, and we have a plan view in cross sections. So having said that, let's get into how these work. So all tree trenches or all green stormwater infrastructure really follows the same principles in the 5 basic steps associated with the components to function properly. And that's the collection or the collecting of that stormwater from the gutter line, the capturing of sediment and floatables and debris, then followed by moving or taking that water after that sediment's been settled out and directing it towards your filter. And then you have the main filter component, which includes your trees and soil media, as well as plantings that provides uptake of some of that water and nutrient. And then lastly, or the 5th step, is overflow. When the filter hits capacity, how does the water get out of that practice, and where is it directed to? These components will be referenced throughout the guide. And I really want to point this out. This is an important thing to keep in mind for all people who are considering the use of this practice, is that if one of these steps does not function properly, so that means if it's not designed, installed, or maintained properly, the entire system could become compromised, and the practice itself could then be contributing to more frequent maintenance burdens on healthy trees and localized flooding and possibly costly repairs. And then just there are 2 types of tree trenches, as I mentioned, and what we've done in this guide is we've taken all of the tree trenches with the many different names, whether it's infiltration gutter, bioretention curb, inlet planter, bioretention swale, biostrip, tree filter with storage, enhanced tree trench, and tree filter pit. There's a lot there. What we've done for the purpose of this guide, we've basically simplified them into 2 basic categories or types of practices. Excuse me. The first being the surface tree trench, which provides stormwater filtration through an amended soil media, and then infiltration through the subsoils. Then the second being the subsurface tree trench, which provides stormwater storage in a gravel bed and infiltrates stormwater through these subsoils. I just want to point out that both of these practices still follow those 5 same steps or include those 5 same components, and we'll be getting into that in a little more detail. So at this point in time, I'd like to turn it over to my colleague, Ellen Biegert, and she'll take a closer look at the guide.
Hey, so I'm just going to look into the details a little bit more of the guide and highlight basically what Brian and Brian were both saying about the overview. So the first thing is who would use this and why. So like Brian mentioned in the beginning, this would really be for people to understand the different options in relationship to the components that Brian had mentioned, and to use this guide as a companion so that these can be designed for individual sites as someone's looking at it, and to talk with engineers and designers about what's going to fit best. Also, of course, to make sure we're including trees in all of our practices and that they are in places that they will be healthy and provide the most benefit. And this image shows just a few of the benefits that trees provide besides just the stormwater benefits. So also with human health, bringing down urban heat island effect, so that we make sure we're creating systems that include these trees that will be around for a long time so that they can provide additional benefits, especially in tough urban situations where they will improve health, help out with stormwater, and countless things that I'm sure we all know trees help with. So a big part of that is when we are just starting out thinking about where we're going to be putting the tree trench or what we're going to be doing with it, is how do I make the site the best for the tree, or is it right to be including a tree trench here? Some of the questions that you would ask yourself is if there's enough room for roots and canopy, if there's going to be a tight streetscape, is there a certain type of tree that I should be using, or are there areas to expand where the roots will grow to? if there's any other site constraints that might affect the tree, if there's utilities or high groundwater that might affect how it'll grow, including to what typical root patterns might be with this and how that might affect the space that it's filling out. And then when asking these questions, seeing if there's ways to improve it. So if there's products that could be used to provide more root space, especially in these urban areas, if we could expand to some of the green space close by, or if there's enough room for the canopy, especially in some of these situations where there's a lot of impervious, making sure there's enough room for it to thrive over many years also. So after going through and asking yourself about the site constraints, is the site conducive for the tree or the tree trench, then it goes into the design matrix, which Brian had highlighted quite a bit. But one way that we have been thinking about the design matrix is as a Mr. Potato Head toy. And this is really because they're both made of many interchangeable parts. So we've been thinking of those as the components. So when you're first looking at your site and going through the constraints, you decide if you'd want to go for a surface practice or if it makes more sense to go for a subsurface practice. And then from there, it would start to break down into the different components that Brian mentioned. So collect, where is the water coming from that I want to start to capture it, into the sediment forebay, then move over the weir into the filter area where it would do most of the cleaning, and then eventually how is it going to overflow. So we'd be thinking through each of these and then looking at how or what we could be using for each of the components. So like the potato head, these are like the different areas. So for eyes, how we can, for that toy, you can change out the type of eyes that you're using, or for the mouth. So then after looking at the components, it gets into the design matrix, where it's the different types of features you can plug in, how we were saying. So you would go through the advantages and limitations, the use, construction and maintenance for each of these different types. So maybe you'd be looking through this, and concrete looks like it could be an option because you like how easy it is to shovel, or if you're going for a better design aesthetic, if cobblestones will make a lot more sense for your site context. So you can go through each of these and see which one's going to fit best on your site. Within the design matrix also, there's overall considerations that would apply to each of these. So for capture or two, considering if you need an permeable spot to make sure there isn't puddling in this area. And then each of the components has its own section. So for move or the weir structure, there's different options that you can look at, that maybe something that's metal because it takes up a little bit of room and you're in an urban setting that needs a lot more space. Or if you have a lot more room, if there's an earthen area that it can overflow then into the filter. And then for filter, instead of just choosing one, it's frequently choosing more than one component for this based on what you're trying to do. Like, would you need soil amendments because there's certain types of pollutants you're trying to remove? What type of tree would be selected? And then if maybe turf makes sense for maintenance purposes for where you are. And then once again, in considerations, making sure we're considering if there's enough room for the tree or what exactly we're trying to do with the filtering part. After the design matrix, then is the typical layout section, where it just takes some of these components, the 1 through 5, and puts them into samples of, if you went through the design matrix, selected certain things, what would it start to look like in plan view, and then also in section, just to give an idea of combining some of these. And just a graphic to kind of show how it works. When you start with surface to subsurface, you look at each of the components, and then each of the components breaks down into individual selections that you can make that would then come together and create the typical layout or the layout for the site that would be selected for your individual site. So that was a breakdown on generally how it works. Are there any questions based on the format or what we've presented so far?
Does look like there's one here that's just asks simply, can I design and install my own tree trench with this guide?
So you would still work with designers, and you would still be using other guides that are available, and they would be using other guides that are available to help with general sizing. But this is really to help understand it and make better decisions, or be able to talk about it with designers also. So you would still need to work with engineers to design out the practice based on local regulations for each of these.
Yeah, I would just add that, as I mentioned earlier, it's really a companion document. So if you were going to design one, you should be referring to your state and local regulatory requirements and their design guidance for sizing and really the more of the engineering or the design elements. But this guide would be useful for both engineers, landscape architects, and I think our hope, as Brian Burns mentioned at the start, is that we can start to create more a healthy tree canopy by not only treating the stormwater, but also designing these practices to have aesthetic value and multifunctional benefits. So I think that was the big goal of this particular guidance document.
And you kind of answered this one, but it says, how is this guide different from other stormwater manuals or stormwater guides that are out there?
Yeah, I can weigh in on that, and I'll ask my two colleagues to kind of chime in too. I think the big difference is, number one, is we're looking at the components in this 1 through 5 sort of process, that you have these very specific pieces that need to be looked at, and this provides, as Brian Burns mentioned, municipalities and designers with options. And as we said, we're not saying it covers everything. We're hoping it encourages some additional creativity as well. And I think one thing that we all took away from this is we really tried to focus a little bit on the trees as well. And that's why we included some good housekeeping and a section on the importance of designing these to maintain healthy trees. We definitely had other people weigh in on that side and give us their thoughts and feedback. So yeah, I think those are the main differences. And Brian and Ellen, I don't know if there's anything else you'd like to add.
Yeah, Brian, I think I could add also that these practices are important, but we always want them to blend in to the environment in which we're putting them. So here in Roger Williams Park, it's a historic park. It's a rural area in the middle of an urban setting. So by not installing a big structure that's concrete, we can kind of blend these things in. We do a lot of plantings on the outside of our stormwater structures here, as well as inside. So the plants inside the BMPs will provide contaminant removal, but typically we'll install plantings around them strictly for aesthetics. We want them to blend in. We don't want them to be an eyesore. We don't want to be a red flag, but we want them to perform as well. So I think that's critical in this stick build element, which just means you choose piece by piece. It's an easier way to blend it into the existing conditions.
Right. Yeah, I probably should have added one other piece too, that we're hoping by stripping out some of the more technical aspects that are covered in other guidance and documents and manuals, that our goal is to sort of simplify these and sort of demystify it from a municipality standpoint and from a maintenance standpoint, that people who are actually installing these, that they understand how they function and the importance of these 5 steps and what each one of those steps, what role they play in this process. So yeah, I think that was one of the other things we really talked about as this guide came together.
So, one other question, interesting, that can these be implemented around existing mature trees? So design a tree trench around an existing mature tree.
Yeah, I can answer that question. They can. I think there'd be a level of, I want to practice some caution here that we're not causing damage to the existing tree or the root zone. So obviously the standard practices or good housekeeping that you would use when working around existing trees would apply here as well. And some of that is covered in the tree section in the guidance document. But ultimately, our goal is not to be taking down trees or impacting existing trees that provide good canopy and all the other benefits that trees provide. So we would say we just exercise that, with caution. Ellen or Brian?
Yeah, I would add that, we've had, in the Stormwater Center, we've had lots of discussions with researchers and engineers about trees actually in these stormwater elements or just outside. And do trees installed just outside, or as you suggest, an existing tree and you build this next to it, does the tree provide the contaminant removal that we're looking for if it's not actually in the practice? So some of the problems with it being in the practice are the media typically is a sandy media so that you'll allow the water to flow through at a quick pace. Well, sometimes it flows through too quickly so that the roots of the trees can't draw it up. So it's something that we're still looking at. There's a lot of thoughts on it. And we know trees are important. We want to incorporate them into these tree trenches, obviously. But where exactly they're placed is a discussion that's ongoing. And it's a critical part for the survivability of the tree and the function of the practice itself. So there's a lot of research going on about that right now.
Okay, one other question. It says this, it seems this guide also has helpful information for stormwater surface features that may not have trees. Does this guide have suggestions for modification if site constraints don't allow for trees, for example, shrubs or low vegetation?
Yeah, that's a great question. It certainly does, and I think there is a lot of overlap between, especially the surface tree trench practice that we included in the document with bioswales or biostrips. So it's certainly adaptable. I think as I mentioned earlier, one of the goals of this particular document in applications that a tree is suitable and makes sense, we'd like to see more trees being used instead of just shrubs and plantings, especially in the urban landscape. If there's ever an opportunity to add trees and provide a healthy root zone, that's what I think we're trying to encourage, that we'd see more trees being added. But certainly there are applications such as power lines or utilities that could compromise the use of trees. And I would say, yes, you can still use this design guide if you're doing just a surface practice and trees aren't part of the equation. Do you guys agree?
Yeah, I would mirror what Brian said, that oftentimes in an urban setting, you're dealing with utilities. And while we do our best due diligence to locate those utilities with dig safe or otherwise, there's always that pipe, be it a private line or a street light line, that doesn't get located. And if you're out there, and again, I'm not knocking the proprietary tree filters, they certainly have their place and they are very effective. But you've got this big concrete box and you've got a utility line and you're reacting at a time when the streets opened up and you come across something they didn't expect. It's difficult to move forward with that if you have those constraints. With these type of builds, as you go along and you investigate those things and run into these things, there's more options for you here. So you take that tree, you move that tree slightly to the right or left or back or forward, and then you can still have it there within a reasonable proximity of the practice versus a box that has a tree in it. It's got to go where it's got to go because it's the low point or whatever. So this just gives you a lot more options, especially when you want to go subsurface or surface. I mean, there's situations where you have to do one or the other, and this guide gives you those options, or at least lets you know about different options that you may not be aware of, that we have vetted and tested and know are effective.
Okay, here's another question about costs, and that they're understanding that there's some variability in costs, but is there sort of an average cost for implementing a BMP like this?
Yeah, that's a really good question. Brian may have some information as well. I can say from our experience, the average cost, typically what we would use based upon square footage or treatment volume, it's usually somewhere, I want to say, in the $7,500 to $9,000 range. But again, there's so many variabilities here. It depends on the material selection, the site, the size. But I would say based upon, the other thing I should add too is if it's a retrofit, which sometimes can add some cost because there's pavement removal and utilities to deal with versus a clean install on a newer development or a greenfield site. There's variability there, but I think that's a range. I think it's very cost competitive to other types of practices. I think the other thing is it's very adaptable, and it's providing what we believe to be more multifunctional benefits than some of the practices that don't use trees or include trees. Brian, do you have any data from the projects you've worked on?
I think you're right on with that budget. And there's two costs you need to consider when you're talking about this type of thing. One is the cost to install it. The other is the cost to maintain it. So again, another part of your thought process should be, what equipment do I have to maintain this? And you should tailor what you install to the equipment that you have. You should also tailor it to the expertise of your personnel. So we do a lot of training in the Providence Parks Department, and our crews are now well versed in the type of practice that we install here. But we don't have a vac truck. DPW does, but we don't have access to it every day. So we don't build things that require that. So it's really important because oftentimes the cost of the construction is far less than the cost of the maintenance. And if these aren't functioning after 3 to 5 years, which is the lifespan of some stormwater retrofits, where there's sediment or other things that are going to clog it up or make it non-functional, those costs can be much more expensive for over 20 years or 30 years. So there's two things you need to be thinking about. What is it going to cost to build it? And what is it going to cost to maintain it? I think Brian's right. It's in the $7,000 to $9,000 range, depending on how many trees you want, and what material you're using for the forebay, how you're collecting the sediment. But the more important thing is its proximity to the street. How easy is it to clean? Because those numbers really add up over the years, and we want these things to function.
Okay, and we do have a few more questions, but I think for the sake of time, we can finish the next section of the presentation, and then we will have a final question and answer segment at the end. So we'll address these questions, existing questions, and then if people have more questions, they can enter them in the chat and the panelists will answer them.
So for this next section, we're going to do a mock scenario. So if setting it up, if we have a spot that we think a tree trench could be useful. Our two actors for this mock scenario, of course, Brian Burns and Brian Butcher, are going to be playing the parts of designer and deputy superintendent. So get away.
Brian, you want me to start it off?
Yeah, good morning, Brian. It's nice to meet you. How are things going? I hear you have a problem in the park and you want to do some stormwater management. So what are you thinking?
Well, we have a body of water that's an impaired waterway. It's impaired because it has high level of phosphorus and nitrogen. And I've got a roadway where I have a puddle because this roadway has been overlaid several times. And now I have standing water in a section of the roadway. So I'm looking to see if I can solve those two things.
How does the runoff drain to the particular practice? Or, do you have any more information on where the site's located? Maybe a photo of the site. Do you have a photo?
I think we do. Right on the screen here, we're looking at that aerial view. So we can see that black patch. That's kind of where the water puddles, and we had to repair the asphalt there. So I guess this is a low point in the roadway, but there's a couple of utility poles and there's a conduit that's on the inside in the grass area. So I've got a couple things I got to deal with. My question is, I've done a few of these. We have a few areas that need them. Does the sites always have to be at the lowest point on the road, or can it be close to it, but not exactly the lowest point.
Well, it depends on what the ultimate goals are, but we can certainly intercept it before we're at the lowest point, because what we're going to try to do is just really treat that first 1 inch of runoff. So we do have some flexibility there. Why don't we take a look at the street view and see exactly where this is going to be located?
So this is a walking and a bike path. So you can see it's got an old concrete curb, and then it's just a vegetated grass area in Roger Williams Park. So it's pretty rural, and there's kind of a lot of room there, but the water's just not getting off the street there. It's just puddling up against the curb.
Yeah, this looks like a great place that maybe we could add some trees into the landscape as well. Would the Parks Department be interested in adding trees into the stormwater practice as well, so we can get a little multifunctional benefits here that beyond just stormwater treatment? Maybe, you know, some streets on this streetscape might add and enhance the experience. What do you think?
Yeah, and you know, we're always concerned with the heat, so we like to increase our canopy anytime we can, and installing a tree in this area would be great. There is a electrical line in there, so we have to be careful with that.
All right, that's good to know. I have a couple other questions. I just want to go some of the site constraints and considerations that we might want to think about. So you already mentioned we do have a targeted stormwater pollutant removal. So yeah, I definitely think you're on the right track here, that we want to do some sort of green infrastructure. And because you're looking at maybe adding some tree canopy, the tree trench might be a good option. What about roadway maintenance? Do you guys salt, or are you sanding? What goes on during the winter time, just so we know what sort of maintenance we might be getting into?
Yeah, we use straight salt here in the city of Providence, and this roadway, because it's a walking and biking path, gets heavy salt use so that we make it safe for our users.
Okay, so that's something we're gonna have to be careful about when we're looking at maybe selecting trees, that we're gonna have to make sure that they're salt tolerant and make sure that we're not going to negatively impact the trees. And we can discuss whether it should be a surface or subsurface practice. What about underground infrastructure? Do you think there's a lot of utilities out there that we need to be worried about?
Well, we know for sure that there's the street light lines has a conduit. It's a 2-inch conduit. It's probably 18 inches down, maybe 20 inches down. That's what we know of. Oftentimes when we put a shovel in the ground, we find things that we're not aware of because we just don't have the mapping that we should. There is a storm system in the street, but it's on the other side of the street, so I really can't connect to it here. So I have no ability to connect to an underground pipe here.
Okay, well, that's good to know. That's good to know, because that will help us decide if we want to be surface or subsurface, I think, here. What about, we're near the pond. Should we be concerned about groundwater? We'll obviously do some test pits out there, but it's good to know before we get started if you're concerned about that.
We recently dug another element in this area, and we did run into groundwater. I think the groundwater was at least 6 or 8 feet down, so I don't believe it's going to be a problem here.
That's great, yeah, because those depths should work. What about stored stormwater and drawdown time? Do you want to store additional water, or are you just looking to filter? Do you want to try to hold and maybe look at some volume reduction as well, or is this just filtering?
Well, it's puddling on the street, so I want to get rid of the puddle, but I don't want to pipe it right into the water. So kind of both. I'm not exactly sure how much water goes there, but it's a big puddle when it rains.
And what about circulation? It doesn't look like, based on the street view, it doesn't look like there's a sidewalk, so pedestrian, circulation isn't an issue. You showed the bike path, so we realize we have to work around that. Anything else related to circulation you think that might be important?
We don't want it to be a trip hazard, so if we can get it off the roadway, that would be good. So people that use that walkway and bike path aren't driving over it all the time.
Yeah, and I'm assuming that between the bike path and the curb line, it's an opportunity for a little separation too, and adding some tree canopy. So what about the contamination or of soil or groundwater? I'm assuming it's in the park, so I would think you have some pretty clean soil up there.
We're not aware of any testing that's been done in this area to provide information about hazardous soil.
But just to let you know, if there is a contamination issue, it doesn't necessarily eliminate the use of a tree trench. It obviously makes it a little more complicated, but there are options that we could possibly line it, or look at if there is concerns with leachability of whatever those contaminants are. So in some instances, we might actually be able to infiltrate even if there is some level of contamination if it's not leachable. So those are all good things to know. So based upon that information, I think we've kind of narrowed down that we definitely want to do a tree trench based upon what you provided. I think what I'm hearing is you'd like to have it more of a surface filtering practice because we don't want to get into underground piping and trying to connect back into the drainage network. So does that sound about right? What you see here, that we'll go with like a surface practice?
Yeah, I mean, it would probably cost a lot of money to go across the street with a pipe, and the pipe might not be low enough on the other side. So yeah, I think probably your suggestion is surface makes sense, I think.
Yeah, so I think what we'll do is, because you're trying to solve an existing drainage problem too, we'll make sure that there's some way for that water to get out of the practice as well. But this will certainly be filtering, and we can look at maybe some additional storage, but we'll start by sizing it for the water quality volume. So now that we've picked our practice, we have a couple different options based upon the design. And the first thing we really need to look at is the inlet. How are we going to get that water into the practice? We have a couple different options. We could do a curb cut right along the gutter line. We could do a tree trench or a trench inlet. If there's a sidewalk or there's pedestrian concerns and we want people to be able to cross, doesn't sound like that's really a problem here. Then we could do a paver flume if it's more at the end of the line, or these are usually used if you're working in a parking lot situation. Based upon what I'm hearing, it sounds like a curb cut might be the easiest retrofit option here.
Yeah, I think so. I don't want this thing to stand out like as this big thing. So I think that's right. Very easy to do, probably economical, I would imagine.
That's great. I just want to add that just to keep in mind when we're designing this and we go to the install, we really need to make sure that the water is going to get into the practice. And sometimes that 90-degree turn is a little tough. So, we'd like to try to lower the grade a little bit in the road, so it really forces that water. I'm assuming you're okay if we have to do a little work out in the pavement.
Yeah, we did a recent patch, and we actually pushed everything towards the curb because it was icing up across the street. So we kind of already got that. So maybe if we just open up the curb, that water will just flow through it.
All right, that's good. So the next step or the next component really is capturing the sediment. And this is really key for maintenance, because if we don't do a good job here, that means we're going to come up with a very unsightly design over time and may compromise how the landscape looks. And we really want this to look good as it's in the park. So there's lots of different options here, anything from a vegetated bottom to using some landscape stone. I hear from that you've had some issues with the landscape stone in the past out of the park, so we'll take that into consideration. We could go with cobbles, a mortared cobble concrete. It's a little more utilitarian, little cost effective, not always the most aesthetically pleasing, or this combination of impermeable pavers with a small opening for some planting, so that adds a nice element. Or also we could use some permeable pavers. So do you have a preference? Is there anything you're thinking that you'd like to use?
Well, we're a historic park. I don't know, cobblestone seems like the most natural thing. We don't want anything that's going to look like it doesn't belong there. So I would say cobblestones, but I think this is where the sediment gets collected. And, I've had problems in the past with my crews when it was a grassy area. They go to pull out the salt and sediment from the road, and they dig up the grass. So the grass never grows because they're just constantly digging it up because they don't know how far they're supposed to go. And they don't know where the sediment they're supposed to remove and the sediment that was, a loomy base for the turf or whatever it is. So it's got to be something hard surface. I'm leaning towards cobblestones. That seems like the most natural thing to install there.
Yeah, so I think that's a good idea. I think we should probably go with the cobblestones. We may want to consider the lower image as well, where we put some plants there to make sure that it drains properly. Do you expect a lot of sediment loading here, or it seems to me that it shouldn't be too high based upon the surrounding landscape? Maybe some sanding?
No, I don't see a lot of sand buildup on the curb line now. When the puddle disappears, there's not a ton of material there.
All right, that's great. And again, as I said, we want to make sure this is going to drain and we're not going to get standing water. So we'll come up with some creative solutions with the use of the cobblestone to make sure water's not sitting there for an extended period of time. So why don't we talk about how we want to get that water out of the sediment forebay? We really need to move it into the filter. In an application like this, I think it's typically creating a weir. Again, we definitely have some options with the weir, we could use stones or even earthen weirs if we have a lot of space, but based upon this site, I don't think that's really a great option. If we wanted to be more naturalistic, depending on the setting, we could use logs. Again, it seems kind of formal here, so maybe curbing or some sort of metal edging might be an option. I don't think gabion baskets make sense. What do you think about using some type of curbing? Do you have any thoughts there?
Yeah, I mean, we have granite curb. We pull granite curb out of our roadways that get improvements all the time. So in my yard, I've got, dozens and dozens of pieces of granite curb. If we could use granite curb, it looks more natural than concrete. And yeah, it's repurposing, which we like to do in the Parks Department. So, economical because I don't have to pay for it. Yeah, if I could use a granite curb, that'd be my best option, I think.
Yeah, no, that's great. We love working with reclaimed granite, so I think granite will be a nice fit here. And if you have the product, that's definitely going to help with cost savings. And yeah, I think that's a good option. So we can move forward with the granite curb. What about in the filter? We have a couple different options here, things we need to consider. I think the soil media, it's going to be a traditional well-drained soil, so I don't think we need to have too much discussion there. But I do know you have some issues in the ponds, and you do have this. You may want to check out the Stormwater Center, the Providence Innovation Stormwater Center. I know they're doing some research on soil amendments and looking at adding things to the soil to help with the pollutant removal. I know they're working with Jamie Houle from UNH, so maybe we want to consider that, and maybe you should stop by the Stormwater Center and see if they have any information for you. Also on the tree, I think we need to think what size tree you want. It didn't look like we had power line issues there, but if we do, it can be a smaller tree. We also want to make sure we have enough root zone to make sure that tree can grow and be healthy and sustainable over time. And then maybe ground cover. I don't know if you had any thoughts, if you want turf or if you want to add some additional plant material to add a little diversity into the landscape as well. So any thoughts on, you open to amending the soil, your tree, or the ground cover?
Yeah, I think if we've got to amend it to make the water flow through it, then yeah, let's do that. Plants versus turf, it's a huge maintenance issue for us. Our guys go into planted areas and they're not sure what to pull out. They pull out the wrong things, so it's really tough to get my guys to understand what plant material, although I think we've made some real strides with that. If there's a way to do turf and we can just get in there and mow it, and I end up with a close to or reasonable amount of contaminant removal in the turf area with the media, I just think that's the simplest thing for me. And particularly in this area, it is a big grass field. So if we kind of blend it in, and my mowers can just come right through and mow it, I think for me, from a maintenance standpoint anyway, and probably an installation standpoint, that's the best option.
Right. Okay, that sounds good. I do think just on the tree, we want to make sure that we select something that's going to be salt tolerant based upon some of your earlier comments. As we advance the design, we can have some more discussion on the types of species and what we may want to use in this particular location. I don't think we need to worry about lining this at all. It sounds like we have good soils out there. And then we can add some additional gravel storage if we think that's something that the parks may be interested in. It may add some cost, but you might be able to hold a little more water, or it may help us out if we have some confined spaces. But it looked like your site doesn't really have those issues. So again, as we advance the designs, these are some of the things we can have further discussions on. And then just lastly, we just need to make sure that the water can get out of this practice in particular. As I mentioned earlier, we will size this for small storm events. So when you get those really larger rain events, we want to make sure that the water doesn't overrun the filter, and the water can safely or efficiently be exit or overflow from the site. So there's a lot of different options here. We could go with no outlet and it just flows out where it comes in. That sometimes can work. We could go add another curb cut. We could add some overflow structures, but that typically would require us to connect into the drainage network. Sounds like that's not the direction you guys want to go at this time. And then, in certain instances, and maybe this may be one of them, that we can just do an emergency overflow and redirect those larger storms down to the pond It would cause, we'd have to do a little more design work there, but maybe that's an option as well if the Parks Department is interested in that. So I don't know. Is there any thoughts on at this time where you're thinking or what direction you might like to go?
Yeah, we did one of these downtown, and it was like I only had like 15 feet to do it, and there was an existing catch basin there. So we blocked up the catch basin, let the water come off instead of going to the catch basin. And then again, not a lot of room, sidewalk on either side. It came through, and then we just put a pipe in as an overflow, and then just piped it to the drain because the drain pipe ran right along the curb line. So we definitely, have used this pipe thing before when you have very little space and you don't have a lot big area. This area is a vegetated area, and it actually slopes down to the water. So there's literally a couple of acres of area that we could utilize for this water to go through. So I don't think we have to pipe it anywhere because it would never flood anything. So probably that's the way to do it.
That's great. This was super helpful. A lot of good information here. We have my really talented coworker is so efficient that she's been listening to this conversation, and she actually came up with the concept design really quickly here. So let's take a look. Does this look about what? Does this sound like something that we may want to start advancing? Does this look about right?
Yeah, the trees are still there, but they're off, so they don't impact the electrical line. And yeah, the water ends up flowing off into the grass. I don't see anybody tripping over this because most of it's off the roadway, and that's a bike lane. So yeah, looks good to me.
All right, well, that's great. So I think we have a good starting point here. We appreciate all the input. I hope you found the design guide to be helpful. It seemed to be helpful for us to sort of weigh our options and to give this some thought before we rushed into designing the tree trench.
Yeah, it gave me kind of a better understanding, especially putting in words that I understand, like collect and move, versus pre-treatment and all these other things. So yeah, it helped me out.
All right, this was great. Well, thanks, Brian. I'll be in touch once we advance the design.
Thank you, sir.
Okay, excellent job, Actor 1 and Actor 2. If you don't already have agents, you better get one because they're probably going to be knocking at your doors. So we have a few more questions. So if people have any questions based on that mock scenario, you can also put them in the question and answer. First one is sort of a budget question. It says, does the city provide any support for maintenance or pay for these systems or trees?
So the birth of the Stormwater Center really was a byproduct of a consent agreement between the City of Providence and the Department of Environmental Management. So we were mandated to build 42 stormwater sites around Roger Williams Park to reduce the phosphorus loading by 85% into the ponds. So with that, we knew we had to maintain it. And as a municipality, funds are always difficult to get. So I didn't think there was any way, after spending $1.5 million of the city's money to build these things, that they were going to give me another $500,000 to maintain them. So we, by necessity, trained all our personnel. So we worked with the Stormwater Center and Horsley Witten and a bunch of other environmental folks to provide hands-on training for our staff and anybody else that was interested, different municipalities and DOT. And they came by and we did these hands-on training. So funds are always difficult to get to build these. They're even more difficult, in my experience, to get money to maintain them. So like we said before, I think that's the biggest issue for us here. And I imagine other municipalities across the country, because you can get money to build these things with grants or otherwise, but the grants won't provide money to maintain them. So it's a difficult thing. It's a big ask for my crews to take on this, something that they had no experience in, no need to do before, and really add it to their daily workload. We've been successful here in Providence because of this collaboration, but funds for maintenance are difficult to come by.
Okay, here's another question about tree sizing. It says, if root zone is typically about equal to the canopy width, how does a tree with a canopy of about 20 feet survive in a trench 4 to 8 feet in width?
Sorry, I was muted. That is a great question. I think I'm going to want Ellen to chime in here as well. I think one of the things that we do talk about in this guide is looking for opportunities to add structural soil beyond just the trench itself. For example, if you have a sidewalk You can then provide some structural soils or some suspended pavement products to allow for a better root zone and reduce compaction. We also suggest that if there is an opportunity to actually extend out into the road a bit, you can do the same thing on the roadside as well to try to provide a healthier root zone. It's a great question because it is always a problem with urban street trees. And then just on the example that we did in our mock exercises, you can see here, we've put the trees not actually in the bottom, off to the side. And in this particular site, we're lucky because we have a bunch of turf surrounding it, so it should be a healthy root zone. And Ellen, anything you want to add to that?
Yeah, it's so it would be site specific, but a lot of the times when these practices are trying to go into urban areas, it is looking for every opportunity to expand it and to make that a priority so that it is a healthy tree over the long run. So with the proprietary products, we do provide some resources based on NACTO and other places that have given cubic feet that should be used for certain canopies and things like that. So it would be on a site by site basis, which is all of what this is saying, but considering that up front as a priority for these, especially in those urban settings, so that we could get the most benefit.
And I think there's another important point when we're talking about plant material. You know, the guidelines for designing plant material has been, you know, you need to put plants in the basins, floors that are going to survive in water. So we refer to it as trees that like wet feet. You know, the reality is our weather patterns have changed and we don't get the 1-inch moderate rainstorms where these plants are in water all the time. We get 4 inches of rain in a 48-hour period. Most of it flows through this practice and potentially out the overflow. And then for the most time, these plants are in more dry and arid conditions. And because they like wet feet, they don't survive. So it really needs to be a hard look at the plant material that we're installing in rain gardens, because you almost want to change the name. They're not rain gardens anymore because we don't get rain, we get deluges. So they should be deluge gardens. So the changing weather pattern needs to be considered when you're choosing your plant material in particular.
Okay, there was also a question about where you can find this guide, and so I'm going to put the URL in the chat right now, but it's on the Stormwater Innovation website, and you can go and download the guide along with any other reports that we have put out associated with the Innovation Center. And yeah, we're getting close to being out of time. So we are also working on implementing and using this guide in Roger Williams Park to install 2 tree trenches, going through the similar process that Brian and Brian went through with groundwork. And those will be put in the spring. So keep your eye out for those on sort of the eastern edge of Roger Williams Park, and keep an eye on the website. We'll have more information about as those get put in. One final question. It says, what funding sources is Providence using to implement stormwater infrastructure?
So because of the consent agreement from DEM, a bond issue, it was capital improvement plan bond issue that funded not only the 42 sites that we installed, but also improvements to playgrounds and rec centers and a bunch of different initiatives across the city. So it was a public bond that went out that gave us the $1.5 million to do the work that we've done so far. It was to answer the consent agreement.
Okay, and that puts us basically at 10 o'clock. So thank you, everyone. Thank you, presenters, for doing an excellent job. And thank you for everyone that attended.
Thanks, Ryan. We appreciate it being here today.
Sure.
Thank you.
Thank you.
Enjoy the day.